We're 2 minutes early. Let's go ahead and start. We've got a lot to talk about today. Welcome to week 3. I'm still Brother Stevic. I'm still teaching this class. Nothing has changed, even though out my window right now is a pretty significant rainstorm known as Hurricane Ian, who's just starting to move into Orlando area. We shouldn't see him in his full force another 5 or 6 hours. All right. So this week, first of all, are there any questions, comments, or thoughts on last week's activities or anything preemptive on this week? All right. So this week we got 2 things we're going to talk about. We're going to talk about obviously the code that we're going to be talking about with week 3, but this week we're going to get into a kind of a deep dive, not deep dive. We're going to talk a lot about what the final project is. Now, for those of you, if I start recording, I'm recording it. For those who remember, there is 2 options in the final of the class. You can either take the final exam, which is 100 some odd questions, open book, open note, open internet, open friend, open whatever, which will have two attempts to complete. Or if you're more interested in the design aspect of the database and design, there is a final project. And here is, let's go here. So under week 3 in your syllabus, you're going to see the week 3 final options. And we talk about this now because in week 3, this is when you should start looking into and start working on your final project. Both final project and final exam are worth 180 points. And it's one or the other, it's not both. Okay. So what the final project requires you to do is design and build a blueprint for a database, which is an ERD, an entity relationship diagram. Forward engineer your design by using MySQL Workbench, which will give you all the code. And we'll talk about it later weeks. I'll show you how to do that. Develop use case scenarios to verify your design and data structure, and to write test scripts. Okay. If you follow this link to the final project, you will see this page here. Yep. And this gives you a bunch of links on how to go and do this. Okay. So here are your actual deliverables to me for this. This is what I expect you to turn in when you turn your final projects. I would like to see a database design or an ERD for a database for a real world application that contains a minimum of 8 to 12 tables. It used to say 12 tables, but 12 is it's a weird number for databases. And I figure if you hit that range to 8 to 12, so what you'll find as you're designing a database, you'll start with 2 tables, and then 20 minutes later, you'll have 50. Once you understand how the tables flow. I want you guys to stop between 8 and 12. If you hit 8 and your next step is like another 7, stay with 8. If you hit 12, you're good. So somewhere in there. I need you to create all the yes, I don't want this here. That is okay. Get rid of this. I want you to create the ERD and the code to create all the objects. I want you to write me the code to input data into the tables. So if you create 10 tables, I need code to put data into those 10 tables. I insert statements for that. Because the next thing is you need to make test cases and the SQL scripts that support those test cases. So what exactly does that mean? So let's say you, like my student last semester, one of my students last semester, designed a database that will give you the ability to find a park in your area that has specific amenities that you want. So he created a database that had like cataloged every park in a given area and what amenities they had, their times that they were open, were they lit at night, was there water, all the things. He had, it was pretty cool thing. And then he also built into it the ability to rate it how often you visited, and stuff like that. So if you're going to write the test case for that, so if that's the database that you created, you would write the test cases you'd write, or how would people use this database? What information would they want to get out of it that you put in there? In the case of the park database, you might want to know, show me all the parks within 50 miles of me that have a splash pad. Okay. You might want to write a query that shows you all the parks you visited in the last 6 months. You might want to find a park that's good for 5-year-olds. Anything along those lines. So that's when you're doing the test cases, you want to think like the user who's using the database. What would they want to see? What information would they want? And you've got to give them that information in the test case. Okay. There was one student who did a database to track where it was a tough thing that he did, but he wanted to do database for a school to track what teachers taught what subjects in what rooms and what students. Oh man, Mark, you went to the Northern Lights, man. That's nice. I like that. I like that a lot. Sorry, I get distracted by that sometimes. So he wrote a database, and this was quite the undertaking. He wrote a database for a school that tracked what the teachers taught, what rooms they're in, what students were in those classes, what times the classes were. It was basically a organization for a school for class scheduling. So some of the test cases he wrote were, how many students are taking American history third hour? How many students does Mr. Williams have? What students don't have a 5th hour class? Things along those lines. Does everyone understand what I'm talking about for the test cases? Okay. As we go forward in this and we start designing databases together and walk down this road together, we'll talk about test case and kind of how to do them. So the next thing I need from you guys is a mock-up of the user interface. This can be, if you like got a crayon on a piece of paper and drew it and just held it up, that counts. If you use MS Paint, that's awesome. If you know how to do any kind of front-end coding and make a front end, that's brilliant too. I have no expectations for this one. The purpose of this one is so I see that you understand how a front end matches up to a back end. So for example, if you were going to do the park one, you say this is the search window when you're going to look for parks with specific criteria. I'm going to use check boxes over here. I have a box in here to write something ad hoc, and here's the submit button, and here's where the results are going to be. Okay. It doesn't have to be fancy. It doesn't have to be wonderful or perfect. Like I said, I just need to see something that you understand how the front end matches up to the back end. And then finally, I need you to create a PowerPoint presentation, or I've added a video presentation that explains your model, what it's for, why you're using it, why you came up with it, how the UI works, and talk about the scripts. Specifically the test cases. I don't care. I want you to show me the ERD and how the data flows through it. And then I want to start with the test cases, how you came up with them, why you think they're important, why you think this is something that the end user would want to know on your site. So that's pretty much what the final project is. It takes a while to do. I think 1 or 2 of y'all have sent me some ideas that sounded wonderful. So this week and next week, be sussing out like what kind of database do I think is important, and it should be something that would be important to you. It wouldn't be something if you don't like cats, you wouldn't make a database for a cat breeding company, right? Because that's just not going to end well, right? So if you don't like science fiction TV programs, I don't know what's wrong with you. But if say you don't like them, you wouldn't create a database to catalog them, because it just wouldn't end well. You'll get bored with it. So think of something that like I'll give you. So this is the example I give all the time with this class. So about 20 years ago, like in the early 2000s, late 90s, I went to a Chili's restaurant with a bunch of friends, and I had just started getting into coding. I just started getting into computers. I was a drama teacher previously, so this is probably like early 2000s. And we go to Chili's, and the waitress would come, and it'd take her forever to get there, and then we get the order, and we're waiting for our check, and I would say something like, "How cool would it be if there's like just like a little computer at this table where I could just pay for my bill and leave?" Right? And like, if you go to Chili's now, what do they got? Got this little thing. If I were a smarter man, I would be teaching this class. I'd be owning this application at Chili's. But someone else came up with it, and good for them. I put the idea into the universe and they found it. That's great. But something like that. Think of a need that you have, because ultimately, whatever you come up with for this class, for this database, could be something you make. Also, eventually, you guys will be looking for work and jobs in the field. If you have a database that you've designed that you can show them your design, and you're looking for a job in the database world, this should be something good for you to have. So if this were an art class, this would be a portfolio piece. So, so this week and next, come up with some ideas. After that, start designing tables. And next week, on Wednesday night, I'll take a generic idea and I'll start building tables off of it to kind of show you guys how that flows. Okay. So this is what's required of you for the final exam. It is more involved than the final project. Than the final exam. It does take more time. It will take about, I had one student do it in 3 weeks. He didn't do great on it, but he got an okay grade on it because he did it in 3 weeks. It takes about 7 to 8 weeks to get this perfect. Because around week 6 or 7, you'll probably be struggling with how the tables flow, and you'll have more tables than you need. And we'll talk about it and we'll show you how it flows. It's the nature of the beast. But I tell you, once you figure out how tables go, it's super easy. You'll just follow it around and map it on your own. Okay. Any question on that final project? What I'm expecting? I will put all this in the comments of the announcement with the things. You all have this. Inevitably, someone will not watch this video, and in week 6 or 7 is going to ask me where the final project information is, so I can just point them to here. Okay, so if that's good, let's talk about what this week is about. And this week is about the where clause. Back over to here. This week is all about the where clause and how the where clause works, and how to. I'm not going to talk about how to help null values in comparison operations, because I don't have any null values in my tables because I am anti-null. Nulls are the devil. You don't want them in your databases, except for very specific times. And you really shouldn't be doing comparison operations in columns that have null values, because it throws off your results. So, since I'm on the soapbox anyway, a null value means it's kind of like a void. There's nothing in there at all. If you put a space in there, it's not a null value anymore. It's a space. So there's something in there. Null means no data was put in there at all. And if you run it, and if you put that in a column that has important data you're going to search over, a couple of things are going to happen. The null values wreak havoc with your indexes, because there's no way to index a null value. And you're always going to have space. It's called fragmentation or space. You're going to have gaps in your index, so it's going to take longer to run. And you're thinking to yourself, how long can it take to run? Well, if I've got a table of 75 rows and 5 null values, that's not that big a deal. But if I have a table of like 6.8 million rows with 30% null values, that's going to jack up your indexes pretty severely. Okay. Plus, when you're running where clauses off of indexes with columns with where and with the nulls in them, they count. You would think that it's null, so it skips over, but remember your where clauses go R bar through the column, and it will look at each null every time it goes on a pass through. So you want to keep nulls out. Where would you use nulls? Let's say you had a table that had you were describing, you were doing a retail application database, and you had a column in your table under the item where it was description. That could be null. If you had a column in a table that was about, it's so hard to think where nulls belong, 'cause I don't think nulls belong at all anywhere.
I think
Anywhere,
I've got a good example for that.
hit me.
I just had a wonderful couple-day experience at the DMV here in Texas, and
I'm sorry.
I just had an experience with the Department of Motor Vehicles here in Texas. So
Yeah.
obviously they keep track of first name, last name,
Right.
middle name. Not everybody's going to have a middle name. So
Good
if you
point.
have that field in your database,
It would be null.
sometimes it'll be blank.
It'd be null. Yeah. And that's a good example. That's a great example. It's a tricky one too, because sometimes you do search by middle name and you have no choice. But if someone doesn't have it, it has to be null. So that's an excellent example. So something like that, that's where nulls would be required. But for the most part, if you can, avoid putting nulls in your databases, because it does mess with the search parameters, and it does mess with the indexes. We don't talk a lot about indexes in this class. I'll talk about it here and there. I have a video somewhere where I talk about fragmentation and how it happens. But I think like the class after this one deals with fragmentation of indexes and how it affects your searches. Okay, so let's talk about where clauses. So we talked about where clauses a little last week, but we're going to talk more about them in terms of inequalities and equalities. So if you remember back to your elementary school days, you had the greater than sign, the less than sign, greater than or equal to, so less than or equal to, greater than or equal to, and equal to. And then you've got these two. These two are different ways of saying not equal. Now, these two here, generally speaking, in about 4 or 5 different database engines you'll find, this one is specifically for numeric inequalities. And this one is specifically for text inequalities. Both mean don't equal. MySQL, either of these work in either case. So here I've got select title length from film, where length is greater than 100. So if I look at my film table and my columns, I've got my length column, which is a small int. Not this week. I think in 2 weeks, I'm going to send you guys a link, or it's part of a video where I talk about the different data types. But simply put, you've got, when you talk about ints, you've got small int, tiny int, small int, big int, and there's one more and I forget what it is. But it all depends. The tiny int is like negative 122 to positive 1. It's very small. It's just how many bits are used in that number. So a small int is, oh wait, no, tiny int, yeah, small int. So this number can't go beyond 1,000 and change. I forget. Anyway, you'll see this later. So because this is numeric, I'm going to use less than sign or a greater than sign here. So I want to know where, and by this is the thing, if you go over here into your column, it'll tell you what the data type is. So you can, okay, decimal 52 is what you use for money. I don't want to go on a tangent for that, but anyway, so if you go over here, it'll tell you what the data type is. Okay. So I want to stick my title, my length from film, where length is greater than 100, and I run that, and it gives me everything that's greater than 100. I go here, show me everything where length is greater than 100 and the rental rate is more than 5, how many times it rented. Because, sorry, how much it costs to rent. And because I used and, it shows me where both are correct. When I use where and together, it will only return results where this one and this one are both true. Which I have to like. If I put or here, so with this one, I had a result of 610 rows. If I do or, it returns of 1,000 rows. It shows me everything. Or means both either or are yes, and means both have to be yes. Okay. We also talked last week a little about where title is like means sort of, it's close to it. This is in there somewhere. So here I say, show me title from film where title is like a percent sign. Percent is a wild card. So this is going to show me anything that starts with an A. If I put the percent sign here, it shows me anything that ends with an A. And if I put it here, it shows me anything that's got an A in it that's not in the first or last position. Okay. Go down here. I've got these underbars. Okay. This is asking me, show me a title where it's like A, some random letter, another A, some random letter, an E, and a percent sign. So there will only be one letter between these. Oops. Went a little too far. A, random letter, A, random letter, E, the rest of the stuff. A, random letter, A, random, E, rest of the stuff. Same thing here. Give me a title for film where it's CL, random letter, S, random letter, Y. I do this, and I get no results. The one I was looking for, so it's because there's nothing that has one letter between the S and the Y. Now this one here, I think I've got 7 underscores here, and this is the title I was looking for. And this is to show you that this underbar represents one character. If here I have, let's see what I end up doing here. Let's see, 1, 2, 3, 4, 5, 6, 7. So 7 characters. So this is CL, random character, S, 7 random characters, Y, anything after it can go. Okay.
So if you took those 7 characters and used the percent, would it give you the same?
I did
result?
this. Yep. So you can use these spaces and percent signs to your heart's content and trying to find something. Here I have not like. So I had not there. Show everything where the first word isn't the. Show me all lengths that their lengths are not 100. We covered a lot of these last week, so I'm going a little fast on these. Between is another modifier we use. Show me where it's between 50 and 100. Okay. It does include 50. Then we have, so does everyone understand these using the inequalities? Okay. So here I've got one where I say select title from film or length, and I have a query here. This is referred to as a subquery. these can be used in any number of cases, but in this case, I want to use a subquery to get a specific length. To use my where clause. Now notice I use the word in here, not equals or like. That's because this returns multiple values. If you're in development, you call this an array. It's returning an array. So when I say show a length where length is in, it'll show me where length equals any number of these things. So all the lengths I return will be one of these lengths. It's not between, it'll be specifically one of those lengths. So if I run this, I put length here too. You don't remember that original list, but that's all the list of numbers within that list. Okay. So subqueries are a way to get an array of values to do a search against another table. Here I just did something fun because this isn't taught anywhere. This is how you declare a variable in MySQL. And I set the variable to the results of a select query. And then use those results in a query. So instead of using the subquery, I put this information to a variable and I use that variable in my query. This is a very powerful tool using variables to set things.
Teacher.
Hmm?
Question. It doesn't matter where you declare the variable.
As long, no, well, it has to be before you use it. Right? So it always has to be before you use it. But if it's in your code, it doesn't matter as long as it's in the same block of code you're running, it'll always work. Like if I ran this now without that query, without the thing, it'll give me, whoa, how'd you do that? Oh, does MySQL save the value? Oh, that's fun. Okay. Apparently MySQL, this is new to me. MySQL saves the value. Let's change this to D. So let's see what happens if you don't declare the variable first. Yeah. 0 rows return, because it's going to look for that.
Yes.
Okay. When this little symbol here in front of anything means it's a variable. So if it does this,
the add.
Yeah, the at symbol means it's a variable. That in front of it means a variable. That's why if I get rid of the at symbol here, I'm gonna get an error saying unknown column D. Because whenever you use something that's not in quotes, it assumes it's the name of a column. So when I ran this query with nothing, with just the D there, right? It thinks there's a column named D, and you give me this error, unknown column D and where clause. If I put the @for sign in front of it, it now thinks it's a variable. And since the variable was never declared, other places would say, hey, you're using a variable is never declared. MySQL, I found that MySQL is very forgiving in mistakes that other database engines will throw you errors and say very bad things about you if you don't do it right.
So when we call the variable, it kind of runs the query and returns the value, the result.
Right. So because there's nothing declaring the variable here, nothing defining what's in here, it returns 0 results. If I change this to D and then run everything together, it'll give me results because it has the value of D. And you can set as many variables as you want in the beginning of your query and use them all over the place. And, you know, you can add, if the variable is a number, you can add to it. Like, set D equal to, I wonder if this will work. 100. No, yeah. So I did D plus 12. I just like did a quick little aggregate here and did it. Yeah. So I've learned just hey, I learned that. I wonder, let me see something. I'm gonna play something here. Yep. So what's happening here is I'm in this window here, right? And anytime I declare a variable, it'll be permanent to this window. If I open another window over here, it's not going to be here anymore. It's not going to be here. So I grab this and bring this over here. Oh, wow, it still works. Okay. Who knows? My SQL's being crazy today, but that's okay. So I've got to declare the variable, and then I can use it in the query in whatever way I want. And I have to look into why this is allowing this to happen, because this is interesting magic.
I have a question about subqueries, if you don't
Sure,
mind.
go ahead. No.
What are the main reasons for using a subquery, and how often do you actually use them?
It's a really good question. So the subqueries for me, I generally use them. So they're used to get information from one table used to compare it to another. Now, this can also be done by joins, which we're going to talk about in week 5. Okay. The reason I use subqueries is if I'm pulling data in from another database. So I've got these other databases here, right? And I'm not going to get into we're going to talk about how to do this, but I can pull data in from this database into this database, right? And put that in a subquery for comparison. Okay. That's a little more technical for this class. The other reason to do this would be if you had a really complicated query to get the array for the for the where clause. So if you had to get a very specific subsection of data that you can't represent in a join, you would do that. So like if I wanted to know what customers rented a video between the days of like March 1st and March 6th and had a birthday of December 12th, I would put that in a subquery, because again, that in a join clause would be a little complicated. Now, again, that might seem ridiculous for what I'm trying to do here, but that's what, if I had a really complex array that I needed to get into the where clause, I would write the select query for that and use that instead of joining. Okay. The other thing about databases, there's 6 ways to Sunday to do anything. So you could use a join, you could use a sub clause, you could use any number of things. It's just whatever works best for what you're trying to do. It's good to have multiple ways to do the same thing. Okay, that answer your question?
Yes, it did. Thank you.
Mm-hmm. Are there any other questions on this? Because that pretty much reaches the end of my intent for today. And we have 27 minutes left, so if there are no other questions, I'll just go ahead and shoot you guys.
I'm
Hit me.
wondering about, when I was going through the textbook or whatever. There's the one subquery that selects from where title like pet, the percent pet
Mhm.
one. I don't understand. I thought that would return a word with a pet in it, but it returns a lot of different results. Yeah.
Is it this? Was that the query?
Let me.
Was it
I
in the-
threw it in chat here.
Okay. Let's see. Let's look at this thing. Select title rating from film where rating in. Okay, so let's look what we got for result here. Select rating from film where film with title like pets. So that gives us 3. So it's G and PG. So essentially what we're saying is just show me all films that are G and PG. So that's why it's returning so many, because this is saying, this essentially what this is saying, this is a different way of saying this. These two queries return the same results.
So why isn't it? I don't understand why it isn't returning like the pet name.
Oh, okay.
Inside
Oh,
of,
that's because, okay, because here's the thing. So this is the subquery, right? I'm not asking for that up here. I'm just saying, show me the title and rating. This is a separate query altogether. This runs separately. Okay, so remember last week we talked about how queries run, what runs first? And I said, this runs first, and then this runs, and then this runs, right? So in this case, this runs first. So, right, this runs first. Okay, and then this runs, and then this runs, and this creates a little bitty table off to the side. Okay, this essentially creates this. Okay, and then the real query is this. This is what they're showing. I'm not asking here where the title is pet. I'm asking show me where these ratings are. This query has nothing to do with this query. These are two separate entities. Is that making sense for you, Jason?
I understand that the second select query, the subquery will run first, but I don't quite understand how percent pets or percent pet percent turns into GPG.
If I run this query by itself, like if I just take this query completely out of this and just run it by itself over here as just a query that I'm curious about, right? It gives me the results. Okay, just normal query, right? So when I add it to this statement here with the in statement, I'm saying, I want you to show me this information where the ratings are equal to what these ratings are. Okay, this is creating a little array off to the side to compare to. It has nothing to do with what's going on here other than it's giving us a list search. That's why I say this and this are the same thing. Okay, if you still don't get it, we can take some one-on-one time later and I can go through it a little deeper for you. Okay. But subqueries are just a way to get a array of answers to feed into another query. Any other questions?
So the second query just pulls the information, the G and PG rating, because those are similar to the pet
Yep,
title.
yep. Because if I go back over here, I take this title, right? And put it here. And I run this. Oh, I must have insert turned on. I hate that. I hate when I accidentally hit the insert key. Okay, so if I run this, I've got three titles that have the word pet in it, right? And it's PG and PG, a G and PG.
That's what I expected.
So this is what comes from this table, right? This query just gives me this because that's what I'm asking for. I'm asking this query to show me this information. Okay, but this query, I'm saying, show me the title and rating from film, where the rating matches these guys. I don't, at this point in time for this query, I don't care what this is here. This makes no difference to me. I just care about this.
Okay. I think
Okay.
that makes more sense.
Makes more sense? Yeah. Yeah. So like I said, that's why I say these two are the same query. Just this I've hard coded. So the difference between this query and this query here is if I run this one, it'll always be G and PG, right? But if I let me do this here. Let me see. Let me find you. Update film set to
Hi, sorry to interrupt.
sure, go ahead.
I just want to let you guys know I'm gonna head out. My
Okay.
kids are being terrors.
Oh, that's fine. Thank you for
Okay.
being here tonight.
Yeah, see you guys.
Mhm. Okay, so I'm gonna use this update command. So I'm gonna update film. We don't normally, but I'm gonna update the film. I'm gonna set the title. I'm setting title equal to airport pet lock, where it's currently airport Pollock. Okay, so I'm gonna change the one value. Okay, and now if I run this, just this one little query here, I now have an R rating there, right? So if I run this one, I'm just gonna get the G and PG. If I run this one, I'm gonna get the R ratings as well. Okay, if I do this, this is a static query. It will only ever return what's in this little array that I built. If I do this, this is known as a dynamic query. If this table changes, this query will change. If this table changes, this query will never change. Okay. So you can absolutely hard code the values in for G and PG. But if for some reason you need this query to be able to vary based on what the actual data is, you've got to do something like this. Let me fix this back before.
I got a question following the same line.
Hit it.
Would it be better to have a variable instead of using like the subquery? You know, because the subquery, like sometimes it's kind of confusing for me too.
So
I wonder if I use a variable, it would be easy for me. Is that like the best practice in the industry? Or
the
should I try
only,
to
okay,
use the
so-
subqueries?
okay. So with a variable, you can only use a variable if you're using one value.
Mm,
I could not put this into a variable.
right, because it's an array, right?
It's
Okay,
gonna be an
that
array.
makes sense.
Okay, if I was doing like, where was this? That, I could put that into a variable because that's gonna be one value. Right? That can absolutely go into that variable. But this, I can't put into variable. Where you would really use,
Okay.
so this is there's something called a stored procedure. And a stored procedure is saved code that you create that instead of running this, you'd give this a name. This is not exactly how you do it. Okay. And then you'd run this, and then alpha, and you run this command called execute alpha. Okay. And then that would run the stored procedure. So it would run this code that you have in the procedure. The reason you use variables is you put variables in the stored procedure so that when you call alpha, you put in your variable and it passes through. If you guys want, I'll make a note like week 12, 13, 14. I'll show you how to create stored procedures and how to execute them with variables. But that is like way beyond the scope of this. Stored procedures are super fun, but that's where you use a variable as to pass something from the outside into the query. So variables are generally used for user input.
All right.
Just a question of curiosity with your select title rating, and you've got the G and PG hard coded right there.
Yep.
Could you have one variable for G, one variable for PG, and put them both in there, or would that not work?
Oh, you could, but then see that. So that's a good question. So I could do this. So I could do set at R be equal to G, and then I could do set at T equals PG. And then I could do right. I could do that. It's still hard coding it, but I could do it because the question is here, what if I need another variable? Yeah, it's still, this still is, where'd it go? Oh, it's up here? Nope. I must have deleted it somewhere. Oh, here. So that is still hard coding these values in, even though it's a variable. I could now change these what I want, but it's only ever going to be 2. If I needed a third one or a fourth one, then it becomes a problem. I've got to change my code. And this comes into table design as well. I never want to make a table that a change would have to would force me, a change in scope would change to force me to change the table. I don't want to have to add columns to the table after the fact. And I can't think, this is something, I'm sure this will come up when we start designing tables and designing databases. But when you look at your code, when you look at your queries, when you look at your tables and structure, you look at it and say, okay, 5 years from now, is this table structure still going to hold? Right. So for example, let me do this here. File. Nope. I don't want to have an existing model. Go for, there you go. Here, let me give you an example. New model. Okay. Okay, so I've got this thing here, and I'm going to go ahead and create a new table. And I'm going to create a table called employee. and we're gonna play a game, and we are in the year 1985 making a database. Okay. So I'm creating this table called employee. And in here, I'm gonna have name, first name. And this is gonna be a data type of varchar 255, thank you. And then I have last name. Actually, I broke the cardinal rule here. That's gonna be the second column. The first column is gonna be employee ID. And that's gonna be int. There we go. Okay. What? Okay. And then I'm gonna do last name here. And then I'm gonna do phone number just for, okay. And I look at this table and I say to myself, I'm never gonna have to add anything here. Nothing's gonna change. Nothing's ever gonna change. And then 1995 goes around, I'm running the same database. I'm like, everyone's got something called an email address. I'm like, oh no, I need to add email address. So then I would alter my table. Altering a table requires you to alter every query that you have going against this table, right? So you got to be careful. That's why I'm be careful about altering tables. Same thing with queries. I don't want to have to add something to my query because something has changed. If it needs to be dynamic, I need to stay dynamic. Okay. So here, this is still hard coding. Yeah. Okay. So I lost that. I should probably put that. Put that query back here. So when I put the code out there, it still works for everybody. So this is back, right? Oh, that's rating. That didn't work because I was trying to get the rating where the title where the rating goes. There we are. Okay. Does it all make sense about hard coding and keeping things flexible and dynamic queries and things like that? Okay. Good.
So can I just take a stab at explaining the the query there? Because I think it's starting to make a little bit sense.
This one here?
The yeah, the one that I wrote in there.
Sure, hit me.
So it's asking for title and rating from the film, but it wants me to select from any of the Pet movies and what the rating was from the Pet movies.
Yep.
And it'll take all the movies that are like PG or G because all the Pet movies were PG and G.
Correct.
Okay.
Bingo. That's perfect. All right. And as an added bonus, you learned how to write a really basic update query. Side note, I'm not going to do this because I've done it before. When you're writing code like this, and you're highlighting and running it, make sure you get everything, because if I did that and ran it, it would change every title to Airport Pollock. And there's no way to undo it. So when you're doing things like me, be very careful, because you can. I've done that on databases I've been working on in a production environment, and it gets very, very sad very, very quickly.
Just out of curiosity, why do you highlight them and use the first search instead of just using the second one?
Just because I've gotten used to doing that. Because this executes things underneath the keyboard cursor. See, so this is like where you learn old habits. when I code in Microsoft SQL Server, I highlight and then the F5 key. That doesn't work here. It makes me very sad. In Microsoft SQL Server, when I run this, the first thing there is a green arrow, and that's what I'm just used to hitting. So
Got it.
that does the same thing. Yeah, see, that doesn't do the same thing. Oh, it did. No, it did. It does do the same thing. I just go for the first one. Yeah. For a second there, I thought it changed everything. Yeah, that's just why I do it.
Makes sense.
Yeah, and you'll find that the more you get do this, the more habits you get into, no matter what environment you're in. Because this looks like SQL Management Studios. It looks like Toad. It looks like, and this is the Workbench. So everything looks roughly the same. You know, but like I said, F5 doesn't work here. Which, if it did, I'd be happy as a clam. But it don't. So, any other questions? Because we're pretty much at time. We'll talk about design databases next week.
No question, but I would like to ask for, you were saying before that you have information about how to query for a different database. Do you mind posting that information?
That is, so we'll talk about that. If you want to do that, like when we hit week 13, 12, 13, 14, I'll talk about it then. That is a very complicated thing. How to tell this database to talk to this database isn't difficult. It's not horrible. When I was talking about databases, talk to each other, like if I wanted this database to talk to my database like in Uzbekistan, that's not directly connected. These databases are on the same server. I'm talking about different database, but I will give you that code. I probably won't do it this week, but I'll get that code to you. I'll owe you that code before the semester's over.
All right, thank you.
Fair? Okay, good. Any other questions? All right, so I will make a note that I owe you guys two things: how to construct a stored procedure and how to query a database that is different than the one you're currently in. And I'll get you that before week 12. And I'll probably just do an announcement on it or just do a quick video on it. Just so you guys have that. If there are other questions, comments, or queries, I will close it off this weekend and I will continue watching the rainfall from my window. As we are currently at, I think they said on the news an hour ago, we were at like 8 inches of rain since 6 p.m. Welcome to Florida, where the rain never stops. I remember I was visiting my daughter's school in Logan, Utah, and I was talking, we were there Labor Day weekend a couple of years ago. And I was talking to her science teacher, and I said, yeah, we're here, but in Florida it's raining. We've had like 14 inches of rain the last 2 days. And she's like, we get 6 inches of rain a year. I'm like, wow, I live in a swamp, you live in a desert. That's how it generally works. But all right, guys. If there's nothing
Sure.
else, huh?
Thank you.
All right. I'll see you guys next week. What's that?
Don't you have a hurricane?
It's happening right now. It hasn't fully hit us yet. It's about 50 some odd miles away. It hits west coast of Florida, but it'll be here in a little bit.
Stay safe.
Okay. Stay safe.
So I'm
Thank
gonna try. I'll see you guys next week.
Thank you, teacher.
Thank you.
See ya,
Bye-bye.
thank
you.
you. Bye.
Bye.